What's your name?
My name is Ernest Rutherford.
What was your early life like?
I was born in New Zealand in the year 1871. My parents were named James and Martha. As a boy, I was surrounded by hard-working individuals. Two of my brothers passed away by drowning. By the age of 10 years old, I received my first science book.
Tell us about your education.
In 1807, I won the scholarship to Nelson College. I attended the school for 3 years and played the sport rugby. During my time there, I won another scholarship to the University of New Zealand. I got a master's degree with a double first-class honors. Several years later, I left New Zealand with J.J. Thomson at Cambridge University. Here I coined the term alpha and beta ray. I then became a professor at McGill University in Montreal.
Can you elaborate on how you met your life and give us some information on your family?
I, during my time at Canterbury College in New Zealand, was housed with the secretary of the Women's Christian Temperance Union, whose name was Mary Newton. Later, after my 10th year at Cambridge, I married her daughter, and we have one child who is named Eileen.
Can you elaborate on your research and others that you worked with, as well as your accomplishments throughout the years?
In 1895, I was the first ever to be a research student for the Cavendish Laboratory in London. While studying there, I discovered a new way of detecting radio waves by working off Hertz's work. I worked with J.J. Thomson to study X-rays. We researched the effects of the rays on conductivity of gases, and we wrote our paper over our findings. I also found that alpha and beta radiation, using uranium and foil, was the result of a single type of radiation being soaked up or blocked, and the other type did not have trouble getting through the foil. In 1903, Frederick Soddy and I really started ideas on the disintegration theory of radioactivity. To further explain this concept, we claim that radioactive energy is emitted from the inside of an atom, and when alpha and beta particles are emitted at the same time, a chemical change across the element will result. Another one of my important accomplishments was when I worked with Professor Bertram Boltwood to categorize radioactivity in elements and a decay series, as we called them. I received the Nobel Prize for Chemistry in 1908. In 1914, I was knighted. In 1931, I was granted the title of Baron Rutherford of Nelson and was elected to the position of the Institute of Physics, also in 1931.
Do you know of anyone who improved on or proved any of your research wrong?
In 1912, Niels Bohr adapted my structure to Max Planck's quantum theory. Blackett later took from my discovery of nuclei of select light elements of nitrogen could be disintegrated by the impact of energetic alpha particles that originate from a radioactive source to result in fast-moving protons, to prove that the nitrogen could be transformed into an oxygen isotope.
Can we visit the end of your lifetime and your views on the future?
I passed away on the 19th of October in the year 1937 from problems of a strangulated hernia. I was 66 years old, and I was buried at Westminster Abbey. I left behind many traces of my work, and many of my discoveries were to become the basis of the European Organization for Nuclear Research. Construction of the Large Hadron Collider was also a part of this research. For the future, I think that we need to further advance our understanding of the research that I began to better understand these building blocks of our world and better contribute to the scientific world.
Hello, I have returned to tell you that Ernest Rutherford earned it.